All right, today we are diving deep into the heart, specifically into two major problems that can affect its most critical valve. We're talking about aortic stenosis and aortic regurgitation. Now, these might sound similar, but they are completely different stories, with two very different ways the heart tries to fight back, and two paths that, if left unchecked, can lead to failure.
So let's just frame this with a really simple idea. Picture your aortic valve as the main exit door from your heart's powerhouse chamber, the left ventricle. Its whole job is to swing wide open to let oxygen-rich blood out to your entire body, and then snap shut to make sure none of it leaks back in. It's a perfect one-way door. But what happens when that door breaks? First up, let's talk about aortic stenosis. And if we're sticking with our door analogy, this is a pressure problem. This is the door getting rusted, stiff, and basically getting jammed shut.
Simply put, stenosis just means narrowing. For a bunch of reasons, often just age and calcium buildup, that valve opening gets really small and stiff. So now blood can't get out easily. The heart is trying to push blood through a door that's only cracked open. You can imagine the backup, the traffic jam. It creates a huge amount of resistance.
So what does the heart do? This is where it gets fascinating. To force blood past that blockage, the left ventricle has to generate way more pressure. And its response? Well, it basically hits the gym. The muscle wall goes through something called concentric hypertrophy. It gets incredibly thick and powerful, kind of like a bodybuilder bulking up. For a while, this works. It's a brilliant adaptation, but there's a catch. That super thick, stiff muscle has a hard time relaxing to fill up with blood for the next beat. And over time, that powerful, overworked muscle just gets exhausted and starts to fail.
Okay, let's completely flip the script and look at the other side of the coin, aortic regurgitation. If stenosis was a pressure problem, this is a volume problem. This isn't a jam door, this is a door that won't stay closed. With aortic regurgitation or insufficiency, the valve just doesn't seal properly. So after the heart gives a huge squeeze to pump blood out, a whole bunch of it leaks right back into the ventricle. Every single time the heart tries to relax and get ready for the next beat, it's getting flooded with the very blood it just worked so hard to pump out. It's incredibly inefficient. And the heart's strategy for this is completely different. To deal with all that extra leaky volume, the left ventricle doesn't just get thicker, it gets bigger. It stretches and dilates, a process we call eccentric hypertrophy. A good way to think about it is like a balloon being inflated more and more to hold extra air. At first, this lets the heart launch a much larger amount of blood with each pump, which helps make up for the leak. But, just like a balloon that's been stretched out too many times, those ventricle walls eventually get thin, floppy, and weak. So you see, we've got two totally distinct problems with the very same valve, and they push the heart to change its shape in two completely opposite ways. Let's put them right next to each other and see what that looks like. And this right here is the absolute key difference. With stenosis, it is a pressure fight. The heart builds its muscle in parallel, bulking up, becoming a thick-walled, powerful chamber. With regurgitation, it's a volume game. The heart adds muscle in series, stretching out, becoming a big, dilated chamber that can hold a ton more blood. One thickens, the other stretches. Both are pretty amazing ways to cope, but both are on a ticking clock. Okay, so all of this remodeling is happening on the inside, but how does it actually show up in a patient? Well, the way the heart changes its shape directly leads to the classic signs and symptoms we see for each condition. For that pressure-overloaded heart in aortic stenosis, we get what's known as the classic triad of symptoms. These are huge red flags. You get angina or chest pain because that giant thick heart muscle is just screaming for more oxygen than it can get. You get syncope or fainting, especially when you exercise, because the heart just can't push enough blood past that tiny opening to get to your brain. And finally, you get dyspnea, shortness of breath, which is the big sign that the heart is really starting to fail. Now, the signs for aortic regurgitation are a whole different world, and they're all about that massive amount of blood being thrown around. The heart ejects so much blood that the systolic pressure goes way up, but then so much leaks back that the diastolic pressure crashes down. This creates what's called a wide pulse pressure, and you can literally see the effects of it. Patients can get a pounding water hammer pulse, a subtle head bobbing with every single heartbeat, and you can even see tiny pulses in their fingernails. It's wild. It's the body showing you that huge volume of blood sloshing back and forth.
So whether it's by bulking up against immense pressure or stretching out to handle massive volume, the heart's ability to adapt is just an incredible feat of biology. But what both of these paths show us is that even the most brilliant adaptations have a breaking point. And that leaves us with a really big question: how long can that compensation possibly last before the heart's own solution becomes the final fatal problem?